For acceleration due to gravity, as we can see from here, that t is equal to 2 pi square root L divided by g. So now if I rearrange this equation, and if I write that t divided by 2 pi is equal to square root L divided by g, and now if I take square on both sides of the equation, so we will have t divided by 2 pi square, and we will have L divided by g. And now if I multiply both sides of equation by g, so we will have g and g, so this will cancel out, so we will have L equals to g into t divided by 2 pi square. So now if I plot this length on the y-axis and t divided by 2 pi square on the x-axis, so the slope of that line will be g value, right? If I remove this equality sign, so this is a constant of the proportionality, so we can write that L is directly proportional to t divided by 2 pi square root. So if we plot the L versus t divided by 2 pi square value, we will have the straight line, and the slope of that line will be the g value which is required. So now what we need to do is that on the y-axis we need to have L, and on the x-axis we need to have t divided by 2 pi square value. So we will have the straight line, and once we find the slope of this line, that will be our g value at that particular at that particular location we are going to where we are performing this experiment. So now let's plot that graph. So now we need to have the plot this length versus this. So first let me select this data, and then let me select this data, and again insert, and then we will plot that scatter data. But as we can see that if I bring my cursor on one of the data points, let's say, so this says that this is 0.2 and 0.002, so the x coordinate is 0.2 and the y coordinate is 0.021, so this is 0.2 and 0.021. so now the y coordinate is 0.021, but as I have explained that we want to have t divided by 2 pi square value on the x-axis, and here when we select the data like this, so the first data selection always tells the Excel that that this data is on the x-axis and this data is on the y-axis, but in our case we need to have this data on the x-axis and this data on the y-axis. So now how to do it? So click on this brush, this is chart styles. Okay, click on this and then go to select data, right? So select data, and now we can edit this, right? So this is series name, this is x value. So now we need to remove this, and what are my x values? Let's remove this, and these are now my x values. And now let's delete this, select this and press the backspace, and then select this, and now press OK and press OK. So now if I bring my cursor on one of the data points, so we can see that this is 0.2, 0.021. So 0.021 is the value of this t divided by 2 pi square, so which is on the x-axis, and 0.2 is on the y-axis. Now this is the chart title for this is this L versus t divided by 2. So let me write that the length, and let's put L in brackets, versus that. Let me copy this now. So this is Control C and click on here and Control V, and now put it here. So length versus this, and now I'll put the axis titles. So plus axis titles. Now this axis title is, here we have the length. Let me write this first. This is length. This is length and GTH, and the units, always write the units. So length is in meters, and this axis title is t divided by 2 pi. So let me put just this symbol, right? So that we need to have some space here. So for that, we cannot delete this, right? So now I will copy this and paste again so that we have it here. We can make it small as well. So let's make it, okay, let's decrease its font size, right? Now again, as I have told you people that the straight line will fit for this data. So again, we need to click on this plus sign and we need to add the trend line. So this is the trend line, this is the straight line fit, and then we need to have the equation, right? So if we have the equation, so we will have the equation like this, y equals to mx plus b. So now on the y-axis we have length, on the x-axis we have t divided by 2 pi square value, and the y-intercept and the slope will be the g value. So now when we fit a curve and if we bring that equation, so the slope of that equation will give us the value of g directly. So now again click on this plus, this trend line, click on this and more options, and here we want to display the equation. So display equation on chart. So now the slope of this line is 9.9241 and the y-intercept is minus 0.0047. So from this we can say that the g value at that particular location is 9.9241. But this g value, the slope of this line, depends on the number of digits after the decimal place, right? So as we have rounded this to 3 digits, so if we remove this round formula and if we use the general values, this is 0.06, and if I double click, so now since we have increased the number of significant figures after the decimal place, so then it gives us 9.7874. But the number of significant figures or the number of digits after the decimal place depends upon the experimental data, right? So if the time for swing is up to 2 decimal places, so then keep it up to 2 decimal places, right? So if I keep it up to 2 decimal places, so again we need to put that round formula. So just press Ctrl Z to undo that, and this is round, and then let's say if this is up to 2 decimal places, so if we put it up to 2 decimal places, then the g value is 10.05. So if this is until 3, okay, this is up to 2 and double click, so then 9.64. And if we make it until 3, this is 3, and then to apply it to all, double click, this is 9.924. So again it depends on your number of digits after the decimal place. So but this is how we can use the experimental data to have the relationship between the time period and the square root of L, that is the chord length, and this is the graph, that is the length versus the t divided by 2 pi square. It will be again the straight line, and the slope of the trend line will give us the g value. So I hope this tutorial will help you in your future labs while you people are performing some experiment, whether that is related to the engineering vibration or some engineering dynamics. So I will recommend you people that always use the Excel sheet. Just do the theoretical practice on the paper and then use the Excel sheet and plot, print your results. Right now, if you people want to plot this graph or plot this data, so what you people can do is that select this data and press Ctrl P. So, and then since I do not want to print this formula input and plotting graph, and I do not want to print this gravity, so what I will do is that print active sheet. Instead of print active sheet, I will select print selection. So I have selected this, right? So this will be my table. And similarly, if you want to have this graph on one single page, so what I will do again, I will select all these cells until this point, and again Control P. So now we have that table along with the graph, that is the period versus square root L. Now if you people want to have both the graphs on a single sheet, so make it small. If you press Ctrl Shift, so it will make it small from all the sides, right? So this, and now let's make it a bit large. And then move it here, right? So we will put it here, and then again we will select all this. Control P. Now we have both the graphs, right? So we need to have both the graph of same length and width, right? So let's say select all these cells, Control P, and this is how the results will look on the page, right? So if I print this as a PDF, since we don't have any printer, so I will print it to PDF. So print, and let's keep this on desktop. So this is my simple pendulum experiment. Save. And so this is our table having that data, and this is the period versus the square root L, and this is the length versus t divided by 2 pi square, and this is the trend line equation, and the G value is 9.9241. So I hope this will help you, and if this helps you in your learning, do subscribe my channel and recommend it to your colleagues and friends as well.